I know? Yes. Thank you, Mike. All right, so okay, that's better. First of all, for all those who keep sending me messages that we don't have access to the quiz thingy, section B has the quiz tomorrow, so that's why they got it. You're going to have the quiz the next. It's on Friday, so you're going to have it later. I don't know. I haven't designed it yet. Okay, when that, so I told them what the questions are. Your questions are going to be a little bit more because you're ahead, they're behind. But don't worry, as we go forward, you're going to have less stuff because you've already covered this and the other one. So it all balances out. Anyway, it's different. Like the 2 classes of 3, 4, 5 are completely different this semester. And if I show you the schedule, because you have the lecture today and you have your lab on Friday. The other class, they have the lab tomorrow and they have the lecture on Thursday. So it's completely bananas. Everything's upside down. There's no way I can sync it. That's why I'm teaching 2 separate completely sections. You're not in sync at all. So having that in mind, let's start. So the very first thing that I want to do over here is showing you a new syntax for writing your functions in C++. So we are not using like we used to. So if I wanted to have main return an integer, right? Int main. And in here I will say return 0 and cout OOP345NAA January 27th, right? So this is what we had, and life was beautiful, right? Now you're not doing that anymore. You're saying, find out what the return statement is, and this thing returns an int. Okay? So essentially, why we are doing that? Why because that functions not in a signature of the function in C language. It's only in the name of the function and the arguments, right? Now we are bringing the arguments back so it can actually decide what the return statement is later. Later on, we're going to learn as we progress through the semester that sometimes your function, you don't know what it's going to return. The return the type that it's returning depends on the types that it's going to take throughout you'll see, okay? So for now, just have it like, you can practice it like this. Just put out over here and an arrow and put the return type over there. No difference. It's the same thing. So I'm going to do this do it like this over here. So now I want to we are talking about functions today. So I want to write a foolproof get int, okay, something that receives an integer. So what I'm going to do over here, it's going to be a function get int that returns an integer. So that's the prototype of the function, okay? And if you want to write the function, you do the same thing. Here you go auto get int that returns an integer. And obviously, I'm going to have something like int number that I'm supposed to get and return null. So usually, that's how you start the function, right? You want to return something, you put a thing, and then you set it to whatever you want. So because we want to have foolproof thingy happening over here, I don't bother usually fiddle with the conditions at the end of interacting with user. User can do so many things wrong. So for me to know when I'm supposed to go back up and ask for the thing again because user entered something that was not proper for the entry. That's why usually I do something like this. I go a bool done, and I'm going to set it to false, and then I put that one in the condition of my my loop. So I'm going to have something like do, and I'm going to have while over here not done. I want to do, and set the condition of the true. And I have to write that. One of the stuff as I'm going. Are we good to this point? All right. Obviously, the very first thing that I do is to get the number. So I get the number. I'm going to check to see if it failed, right? And I'm going to have an else. So if it failed, it means user entered something. You know, this is OOP345, but just a quick review of what we've done. And after I've done this, then I'll show you some good stuff that are about to happen. Okay. So, okay. All right. All right. Yeah. Mute yourself when you log in, please. Thank you. So, so if it fails, first of all, I apologize to CN. Say, I know something went wrong. Please, let's be friends again. And then after that, I'm going to say cout something like invalid integer. And try again. And go to new line and get the value in the next loop. Okay? Then, but if it's good, then I have to see if, because we know it's buffered entry, so when user enters the value, user enters 1, 2, 3, 4, 5, that's valid. But if it puts 1, 2, 3, 4, 5, A, B, C, D, then that's invalid. Cin by default skips all the white spaces and gets the number, and whatever is after remains in buffer. So I have to take a peek and see what comes next. So if the next thing that is coming in, I'm not going to read it, I'm just going to take a look at it, is not equal to \n, that means user entered stuff that are not supposed to. Good? So now I'm going to say only an integer, please. This is not false, so I'm not going to. So Cin didn't fail. C isn't good. Cin is good, but the user entered something incorrectly. Only an integer, please, and go to new line and get it again. And then after all these things are done, no matter if they fail or not, if they are here, if they enter something perfectly, I have a new line in a buffer. If they fail, I have garbage in buffer. If it didn't fail and they entered something more than an integer, I have the integer in num, but the rest is garbage. So over here, I have something to dump. So at the end, I'm going to say cin dot ignore and up to \n and then stop, right? But if everything is okay, then done is true. Right? That looks like a good full entry thingy. Will be okay back there? Oh, you're actually watching over there too. Okay. All right. Just love to be end. cout number, and I can have integer num is set to get int, cout you entered run forest run, and 3 years later it compiles, and we'll try it. So first, garbage entry, see if it's okay. Invalid integer, try again. My invalid is invalid because it says evalid. I have to fix that. Well, anyways, so now I'm going to say 1, 2, 3, 4, and then I'll put garbage. Only an integer, please, and I'll put 1, 2, 3, and now you enter 1, 2, 3. So we're good. Okay, so first of all, let me fix that invalid thingy. So what do I do? Let's see it, but over here, okay, that's much better. So now what I want to do over here is use this getInt for something else. Say I want to rent a car, and people need to be adults to do that. So it has to be over 18. So if I want to do, what do I do? Either I have to create a function called getAdult age or something, and then call the getInt in it, or I can insert a function in there. I can have something like how old you should be to be able to drive. Do we have anything? Let's say if you're more than 100, then you have to, I don't know, go reevaluate to bring in other people. I think this actually happens when you're more than a certain age. You have to do cognitive tests and stuff like that. So let's say it's 100. I don't know whatever. I'm just trying. Okay. So no, I'm not going to do that. I'm just going to say if it's greater than. I'm going to say. So let me bring the function in here. So this is the function I want to write. All right, so that's an adult and we're good, right? So if I want to actually insert this into the function, what do I need to do? I need to write it right after here. So after here, right before I say everything's good, I have to actually check to see if it's adult or not, right? So in here I have to say else if is adult, and I put the number in it. So now that I have a valid number over here, then it's done. Else in here, I'm going to say cout, what do I write? Only adults over 18, please. Something like that, right? Are we okay with this? Now I want to write the exact same thing for number of students in a class. So I want to hold the class and see if the class can be held or not. Right. So what I need now is to actually have a valid number of students for a class. And I would say a valid number of students for a class would be something like number between 10 and 35. If it's less than 10, no class. If it's more than 35, new section. Whatever, right? So now I have to change my source code again. I have to take this is adult out of here and put valid number of students, right? Right? Wouldn't it have been nice if I had a variable that I could have hold a function in it? and pass it to get in so I can change it on the fly, so I don't have to rewrite the code, a variable that I can hold a function in. Is that even possible? I mean, like, what the hell? Variable function that you're talking about? But think about it. Isn't a function a piece of code? Isn't a piece of code a series of zeros and one in memory? So functions are data, but a different type of data. Is data over here? You're holding a number of something in it, and you're validating it, right? This function. Now, let's look at this closely. I'm just going to keep this for now.
Excuse me, Professor.
Yes, you were. Yeah, just a second, please. It scared the bejesus out of me. It was so loud. Just okay, let me reduce the one. Okay, go one more time. Go ahead.
Is the session being recorded?
Thank you. It's not actually, but it's being recorded locally, but not on the thing. So thank you for reminding. Start recording. But this was reviewed from OOP345NAA. There's no problem. But thank you very much. Okay, sure. So quickly, let me explain right now. So we wrote. Thank you. Much appreciated. Who was that?
It was me.
It was you. Thank you. I just want to remember
Oh.
who's paying attention to the lecture. What we did over here, first of all, we said that functions are written in a new syntax. You put an auto before the name of the function, and you put the return type after an arrow after the function. That's a new syntax for creating functions. Then demonstrate, have a quick review on validation with C in and C out. We went through a get in, a foolproof get in. In a get in, we received an integer. We check to see if it failed or not. If it failed, we cleared it, print an error message. If it didn't fail, we make sure no garbage is coming after. And then after that, we went through all the things that getInt is supposed to do. And then we said if we want to use getInt for any other type of data entry, either we have to write a new function and call getInt in it, or what we can do is essentially inject some kind of a logic, a validation within the belly of getInt. And we said it would have been nice if the validation function we are injecting into the getInt could be actually be passed by some kind of an identifier instead of keep recompiling the code with new things. And that brings us back to understand something in C language. So what I'm going to talk about right now has nothing to do with C++. It's actually C. Okay? So not to get confused because of the new syntax of the function, I'm just going to switch back to good old one, and we're going to come back to this later. Just remember that this is how you can actually write the functions if you want. So let's say I have two functions over here. One is finding sum of two numbers, and the other one is finding product of two numbers. Are we okay with this? We're okay with this, right? So what is common between these two functions? Their signature, right? They have the exact same signature. Now, when we reviewed pointers a few days ago, what did we say about arrays? We said arrays are really a series of elements in memory with a pointer pointing to the beginning. Now, functions are just of logic in memory, and its address is kept in their name, exactly like an array. So if I write something like this, if I write something like cout reinterpret cast, and I put over here unsigned long, and I put over here sum, in here I'm going to say address of sum in memory. And I'm going to now have prod over here. And if I run the program, you'll see I'm not calling the functions. I'm just putting their names over there. That's where they are in memory. So function actually holds all we need to do to be able to call the function indirectly, like to be able to use an integer indirectly. What did we do in C? We created a pointer, we held the address of the integer, and then we went through the target of the pointer and accessed the integer, right? We can do the exact same thing over here. So how do we do it? It's essentially this. What you do, you write the signature of the function exactly as you have. So I'm going to write over here void. I'm going to call over here func. Okay? And you put over here int and int. Right? That's the signature of the function if you wanted to write a prototype, right? Now I want to tell the compiler, hey, this is not a prototype. This is actually a variable capable of holding the address of any logic that returns void and receives two integers. You follow? Just to show you what I mean, I can have over here void repeat integer a, integer num. And in here I can say for integer I set to 0 and I less than num and I plus plus, and cout a and I plus plus. Completely different thing, but the signature is exactly like those, right? Are we okay with this? So now take a look. Now, to make this thing actually a variable, you have to tell to the thing, not a variable, essentially a pointer. You have to say, hey, this is a pointer, not a function. So now, func is not a function anymore. It's a pointer that can point to any logic that returns a void and receives an integer. And it's a good idea to set it to null ptr, because it's a pointer. I could put empty curly brackets in front of it, but if I did, you would think that that's a function and it's open curly bracket and close for the function. Specifically, I did it like this. If I did it like this, people think that it's which is not. If I do it like this, I'm simply setting the function to that func thingy now. And let me change that thing to func ptr, so we know it's actually a func pointer. So we know that, right? So now in here, I'm going to say func ptr is set to sum. Okay? Now, what I can do over here is say func ptr 10 and 20. And I can change it. Now I'm going to make func ptr point to prod because it's just a variable. Now it's going to change to repeat. And when I run the program, you will see that 3 different functions are going to get called. So now I am actually capable of passing the address of, now, we were there, right? Now, if I want to write the weird syntax for it, then it would have been right? Tax. The other one is syntax. Okay. So let's have them both so we know. Okay. So it's again, we're okay down to this. People at home, are we good? And I see Solar is listening only. So I'm going to ask you a question. Are you good, my friend, over there? In listen only mode that I do not like. See? Listen only is not actually listening. Hello? Anybody home? No? Yeah, all right. Didn't respond. Okay, so we good? Down to this point. Not only that, we can actually do crazy stuff with this. Let me just do something else. So you see this, I'm doing it that way. I'm going to go over here, Alt F-A. So this is function ptr intro.cpp. Okay. See what I'm going to do in here. I'm going to make this an array of 3 pointers. And initialize this array to and now I don't have to run it individually. I can say for integer I set to 0, I less than 3, and I plus plus. I can say func ptri 10 and 20. Right? Now this is calling function 0, which is sum, then calls function 1, which is prod, then calls function 2, which is repeat. So I'm going to run the 3 things back to back. Ta-da! Function array. Again, as I told you, and I told many, many times, nothing new is being taught here. It's all things that you knew. You know what a pointer is. You know pointer's job is to hold the address of something. Now, and in IPC 144, we told you that everything is data. You have 2 different types of data. One data is the raw data that you process. The other data is the logic that manipulates the other, right? That logic is data. It's somewhere in memory. And therefore, that's the direct result. Now, having something like this, I don't need to write 5 different functions for that getInt thingy anymore. I'm going to go back to that getInt now. I'm going to go back to that getInt exactly as it was. I have another example that I have written in here. I'm going to first modify that one and then come back over here and show you a good one. Okay? So we're going to go through it one by one. Okay? So this is, and this already worked in C language, but is extremely low level. Think about it. You're literally extracting the address of logic in memory, and you're indirectly asking the CPU to go over there and execute it for you. So first of all, 2 things we learned today. Numero uno, number 1. Holds the address of the beginning of the logic. That's number 1. Name of the function holds the address of the logic. That's number one. Number two, open parentheses and close parentheses that you put in front of a function is actually an operator. It's a function call operator. If you remove it, it's exactly like index operator for an array. An array's name holds the address of the array. When you put the index operator in front of it, it means go to that place and do something, right? So parentheses operator in front of the name of the function, it means CPU, call it, run it. It means execute. So those two parentheses that you put in front of the function name, that means execute whatever it is. Now, you can pass arguments to it too. With index for an array, you put an integer in there, and not an integer, anything you put in there, it's passed to the function, to the operator, right? To the index operator. It's the exact same thing over here. Anything you put in the parentheses is passed to the operator that calls it. So just two things we learned. Number one, the name of the function holds the address of the logic of the function. Number two, the parentheses we put in front of the name of the function is actually an operator telling to the compiler the code pointed by this pointer is supposed to get executed, and such should be. Okay. Yeah, 3-4 people are okay. But guys, like at home, you have to be able to pay close attention. We are going to kind of new territories now. Okay, so, and all the things that you see in C++ is turned object-oriented now. I have a question. The open square bracket in an array, it means beginning of the array, and close means together. It's one operator. Don't give it extra meaning as it isn't. I know you want to make something out of it, but that's not what it is. Those two together is one operator. That means execute. Now, you can put something between those two operators and pass it to the function, but those two together mean execute. And whatever you put in it, it's carried to the logic. Exactly like an array. The open square bracket and closed square bracket is one operator. Whatever you put in it is carried in. It's exactly the same. Good. Now remove the thumbs up at home so I can ask again if everything's good. So remove the thumbs up if you're okay. All right. So, okay. Okay. So, did I rename it to function pointers? No, I want to see array of function pointers. So a very good question for a quiz. I'm going to give you a function. I'm going to say create a pointer that can hold the address of this function. Easiest question. But for the person who knows what's going on. For the person who doesn't know what the heck is going on. Okay? So, so next is to bring the logic we had over here for that get in thingy and put it in here. So I want to pass this as adult thingy over here, right? So instead of doing that, I'm going to call this is valid. Anything that is valid, right? And I'm going to come to the argument list, and in here I'm going to say it returns a Boolean. This is valid and receives an integer. Right? So is valid pointer receives an integer, returns a Boolean. Any function that has that signature can be carried with this. And as you see, of course, I cannot put over here the message. I cannot say over here only adults, please. I can't do that, right? I cannot say that, all right? But I can have the functions design that. So in here, instead of just returning, I can say, if that's the case, print something, but I'm not going to do. Well, for now, let's just let it be like this. So in here, I'm just going to say invalid data. Invalid integer value. Okay, it is an integer, but it has invalid value in it. Okay, I don't know what validity is. That's why I cannot customize the error. 2 seconds, we're going to do it. I can write any function I want. So in the documentation of get, I have to say my getInt receives the address of a function that validates and returns true and false based on that thing's validity. Right? Now that I have this, I can come over here in my getInt, and I'm going to say call the getInt for his adult. And now call the getInt for valid number of students. I'm just passing the address to it, right? So problem solved. I don't have to rewrite code and I get anything here I have to fix. Now I have mixture of different types of signature writing. That's why I don't write like it. I'm just going to make this like the other one. I'm going to write auto. I'm going to write over here Boolean. Sorry, I'm going to fix it in the other one. I just wanted to. That's something that you need to know. But it's the same. No difference, right? Right? Okay. I just use the new notation for function signatures. The next one I'm going to write, it's going to be normal one. Okay. Now, if I have something like this, I can actually write over here, enter age, and in here I can say cout enter number of students. Right? And now I have 2 ints get. No, bad person I am. Okay, there we go. That's the first one, and this is the second. Why is it giving me an error? Oh, okay. Stupid compiler. Oh. All right, are we good? All right, now if I run it, you'll see that getInt's going to get called twice. Now in here, if I put, I don't know, 10, it's going to say invalid integer value. But if I put over here 20, it's OK. In here, if I put over here 100, that's valid. If I put 5, that's valid. But if I put 20, then that's valid. So as you see, different things are getting called, right? So it's a beautiful thing. I can't tell you. The first time I was studying C, like it was like, seriously, how much time you can save? You just design whatever you want to do, and you can pass different types of logics to it. It means the number of functions you are writing suddenly shrinks to the bone. And also, you can create variables. You can create functions like this and document it. For example, sort. There is a function called sort in standard library. Okay? It's a C function. What it receives address of a beginning of the array. It receives the size of the element, and a logic for 2 elements to be compared. And it sorts it for you. Because that's what you need essentially, right? So these things you can do. And we have the same thing in standard template. Again, nothing is new. They're just become more advanced and become object-oriented. But do we understand this now? We're good with this thing? Everybody, are we good? At home, people, are we good? I'm looking at the people with thumbs up or down if you're not good. Ah, so there is answering now. Good. All right. Aaron, oh, yeah. Okay, leave it for a second. Just a thumbs up and immediately turn it off. So I think they're not. But anyways, the two are missing, John and Hesse. Okay. Anyways, so now I'm not gonna write the other one in here for you because you've seen the get in. Now I'm gonna actually bring the other code up and so you'll see. See, this is now I'm doing the same thing. I'm just gonna say your validation function is supposed to receive an integer and a string reference. If it was C, it could have been a string pointer. But anyways. And I'm saying do the validation. If the validation is bad, set the string error message to the proper message to be shown for error. And in my getInt, the isValid that I'm receiving now receives an int and a string reference. So now here, I create a string message. I show the general error messages that they are in that and if that is valid, true, otherwise show the error message because that's going to set the error message to whatever it is. Now, the person who's using my sophisticated getInt, all they need to do to use my getInt is to write a validation function for me that checks for validity and sets an error message when needed. And the good thing is that we could have, I'm not going to do it here, do it as practice at home. We could actually do something like this. I could have put a default value for null PTR. And now in my checking, maybe somebody wants just to get an integer. They don't want any validity. So in here, I could put this validation inside an if statement to see if actually if this thing is actually valid or not. It's just one thing that I need to do over here to fix it. So I have to say if is valid equal to null PTR, right? So this is not null PTR. Checks the other one, right? But if this is null, then the second one is not going to get checked. Lazy evaluation, IPC 144, remember? Why did you go like that? See, that's why I like to teach in person, because eyebrows tell me what's going on. Lazy evaluation, remember what it was? No? Who knows what is lazy evaluation? People at home. Anybody knows what is lazy evaluation? Really? No? No, it's just a logical thing, lazy evaluation that C does.
The first thing is if it's off,
Yeah, a lazy evaluation means if it finds out what is the result of a logical operation, it's lazy. It's not going to bother checking the rest. If is valid is so and see, I'm going back to IPC, but I have to because I'm gonna use lots of stuff like this, and if you don't know it, we'll be in trouble. This is an OR operation. So essentially, you have something like this comes over here. You have that's one condition. It's a key switch. This is another condition. That's another switch. Then you come down. You come to a light bulb, and then you have a battery in here. That's an OR. Essentially means if one of the switches is on, the light goes on. For this to be light to be off, both switches must be off. Now, if the first switch is on, do you need to bother checking to see if the second one is on or not? No. That's lazy evaluation for OR. For AND, the lazy evaluation is this. So this is an AND statement. This is one switch. This is another switch. and the light bulb and the battery. So for an and, they both must be true for the light to go on, right? Now, if the first one is off, does it need to check to see if the second one is off or not? No. That's lazy evaluation for and. So lazy evaluation means first is bad, everything is bad, that's for and. For or is if the first is good, everything is good. You don't need to check. Yes? Yes, and do crazy fast processing with that. You don't have to write if statements anymore. Crazy fast operations, like you want to count something. If you want to count how many numbers are bigger than 10 in 5 billion numbers, if you write an if statement, each if statement is a condition check and a jump, right? But instead of writing an if statement, you can just write a statement, which is num greater than 10, right? And cnt plus equal 1. No if, nothing. Just that statement with a semicolon at the end. It checks the first condition. If the first condition is false, it wants to try the second condition, therefore executes it. Therefore, the variable will be added by 1. If the first one is true, then the other way, actually. The first one is false. It's not going to check this. The other one, nothing happens. If it's true, anyways. So you can write very well. That's IPC. I'm not going to go through it, but try it. Those type of if statements, especially if you are dealing with graphics programs and things like that, are very normal. Like if you're drawing billions of polygons on some, you don't have time to write if statements and stuff like that. These type of quick statements. So I used it for this. So if it's valid, is null, then the second one is not going to get checked and it's done. If it is not null, then it checks the validity and actually executes the function. Are we good? All right. Are we good at home? Yes, we are good at home. All right. So better get int with func ptr.cpp. Questions down to this point? Suggestions? Objections? Anybody wants to go for a break before we do object-oriented functions, function pointers? No? All right. Okay, so break. Okay, 5 minutes. Please remind me, the lady to remind me to record after the break. No, it's pause recording and pause recording. And let's continue. So let's show you something interesting. Take a look at this. So get rid of all these adult thingy. We don't need this. Let's say I create a class. I call it adding. So this class job is to add stuff. And I'm going to create the public thing over here. And how do I put this in words? So if I if I do something, say, and right over here something like operator, and right over here int val, I can say over here mval is equal to val and return it. And then in here I'm going to say int value this is a complete inappropriate way to overload the index operator, right? Well, what it means is that if I write something like this, if I instantiate adds in here, if I say over here adding add, okay, I can actually say add 25. Right? See out add.val. Are we okay with this? It's the stupidest thing to write. It has nothing to do with index operation or anything like that. As we learned in OOP345, I can overload things in a crazy way that doesn't mean what they are actually supposed to do. So I'm overloading the index operator, I'm doing that. Are we okay with this? And it's going to actually, when I say add 25, 25 is going to go to val, set the mval to 25, and return it. So this val over here becomes 25. So I can print the val, or I can print the value inside the adding class, and it's going to print it out. Are we good? Now, take a look at this. I'm not going to even let that thing be, okay? Instead of that, I am going to overload later function call. Function call. And that, I'm going to say int num1 and int num2. In here, I'm going to say return num1 plus num2, right? And let's make this one number of calls. And in here, I can say m number of calls plus plus, and I can say thank you. You have to hit it to the side. There we go. Okay. The door was open, and now always people are saying, what the heck is that? But yeah, anyway. So number of calls, then in here I can say something like operator, or and make it size t. Size t, number of calls, and return m number of calls. Seriously, m number of calls. Yeah. Now if I say over here cout add the number of calls, obviously it's going to print 0, right? Right? And see what I'm going to do now. I'm going to say A is set to add, and $30. And I'm going to say C out. So what happened here? Take a to get that correct. That's what it says objects. It could be any class that overloads the function call operator. Or they call these functors. Okay? They call these functors, function objects or functors. What's good about them? The good thing about them is that now you can actually pass the function with an object. So no more func pointers. You don't need to hold any pointers. You simply overload the function call with a proper name in a class, and you can pass it anywhere you want. It's an object. Not only that, it's a stateful function call. In function call in C, you pass the address of the logic and you reuse it. But in here, you not only can do that, but you can track and trace things for your function calls and make it meaningful. So it literally becomes function object. If I run this program, it works exactly like a regular add, but the difference is that it's going to actually do that. Now I know how a functor. So functions that class the function call operator. And remember, you can overload it. I can have this add due to two doubles. So the double one is called. Now I can keep track of how many doubles were added and how many integers were added. Things like that. So the sky's the limit. Okay? So that's essentially what we call a functor. Let's save that, EF. Okay? Now, remember the get in thingy? Now, I can create a class called validation. And in that validation, I can overload the operator function call with int and message. And I'm making this an interface. And I write my get in that receives of, I call it int validation, bad name. I should have called it validation or int validation. Int validation is good. Okay? So now I have, by writing this and give it to people, this is not usable until they implement this interface. Which means now if they actually want to have, they have to write something like class is adult, public, int validation, int validation, and all they have to do over here is to overload this virtual method. And in here I can have, let's make it size D. ignore its flaws because of the const return m number of validations. So for this design, this shouldn't be a pure virtual method. It should be a virtual method that adds to the, but I'm not going to do that, okay? But anyway, so now in here I'm going to say public and I'm going to implement this by saying if val is greater than or equal to 18 and val less than or equal 65. 65 is senior, right? So 64. Then OK is equal to true. And then else in here, I'm going to say error message is equal to enter. By doing something like this, getInt receives a valid, and now they can actually pass isAdult to it, and it will work perfectly. You follow? So functors can be used in an object-oriented way to pass logic around. You can enforce, actually, people by creating an interface for the type of validation you want. You pass the validation, then you don't need any documentation. They look at the thing, and they say, OK, so that's how it's supposed to be. That's the interface. I have to modify that interface and do whatever is needed. OK, you follow? Are we good? All right. So
this number of validations is an example of what you can do with this kind of platform.
Yeah. So this the number of validation is like a validation is supposed to be counted, right?
Okay.
If it's password entry, if the validation is no static, then adult will no static. The fact that it's just good. If you need to know what is the total number of validation in your system, sure, you could make it static, but we don't want that. So we know where we are going. So that's functors. Functors are nothing new. They're just classes that overload the function call. Now, whatever function call you are making in there, that's your choice. So that's now, we talked about templates, okay? What if I want to create templates that carry pointer to functions, and how do we deal with that? Take a look at this. And the sort that I have receives an array of elements in the array. It's a template, right? And it can sort anything, anytime. We've done this in OOP345, right? But this one receives a Boolean for the comparison between the elements. So if you have employees, you can sort by the employee number if you want to. So you can pass what you want. Whatever the comparison between the two is, it's supposed to receive the two types and compare them. OK? Now, and it's a pointer to a function of that type. Now, how do we pass if I have a Boolean ascending, or this is a template too, that checks for the ascending and descending. So I want to pass the ascending or descending depending on what we have in here. So the templates over here is supposed to, these two templates supposed to decide if it's an ascending or a descending one. So what I need to do over here then say, if I want to do an ascending sort for integers, then I have to say sort the integer array and pass. So this actually triggers the address. So with templates, there's no difference. Just giving you that what should we call it? The same thing that I told you about everything else. If you learn one concept, you can apply another thing to it, and it works perfectly. Everything is logical back to back. A pointer to a function is no different to a pointer to a function template. It's the same thing. As soon as you put the name of the function and the signature, you're actually triggering the compiler to generate the function, and therefore the address is accessible through the same thing. Are we okay with this? You okay? I don't even need to explain functors and templates because they're classes. Make it a template. Who cares? It's a class, right? We know how to create class templates. So you can create a validation class template or whatever you want. There's no problem. It's a class. Do exactly what you have done to any class. It's the method in a class. And you make the class a template as we. Again, it's like it's dominoes effect. One thing you learn, everything goes after. Okay? So H, EFG H, this was one pointer to function templates. Okay? All right. How much time do we have? We have just a tiny bit. Sometimes things you want to do are so small that you don't want to write a function for it. You just want to write a function and get over with it. Smaller the function in a line somewhere in your code. Like, for example, the adult thingy that we had. Why do I have to write an isAdult function and pass it? I wish I could write it in just one line as a variable inside my code. You can do that. We can actually write functions in one line. That it's not a global function. It's a function created inside a scope like a variable. We call those lambdas. Like, for example, if I want, this is what I can take a look. I can actually do this. Okay? And then in here, I'm going to say, this function doesn't receive anything. Okay? And it says, it returns hello there. Okay? That's a function in one line. Problem is it doesn't have a name. I need a handle to carry it around, right? Right? So wait a minute. We learned that there is something we can use to find out the type of stuff without knowing the types. What was that thing? Auto. So I can simply say auto, hello, done. So now that's a function that returns a constant string. Constant hello. And print the hello. Right? Having said that, let's go back. So this one, let's go back to that integer thingy we had. Was it the first one? This was the one, right? Yeah, is adult thingy, right? So take a look at this, please. So let's say I don't have is adult. Okay? What is adult? In here I can say is adult is a function. Is a function. What is it supposed to? Ta-da. I just wrote the function in the command line argument and passed it. When functions are small and little, you don't need to write a function for it. You just want to use this for an adult and get over with it. Or the other one, number of valid students thingy. Whatever it is, you can just write it in one line and be done with it. So putting a square bracket and function call after it means I'm creating a lambda, which means a small little tiny function. And then you write in it exactly like you're doing. You can write 50 lines in there if you want to. There's no problem. It's gonna be, but if that's the case, then don't write a lambda. Write a function. I could have go over here and start writing hundreds of lines of code over there. Well, why? Right? Lambdas are for this matter. So you want to write small little thingies and be done with it. Okay? So this does the same thing. And do the other one, valid number of students, I can do the exact same thing. So in here, valid number of students is returns number of students being greater than or equal to 10 and number of students being less than or equal to 45. So you don't need that. Right? It makes your life easier when you are doing small stuff. So that's essentially lambda. Okay? Now, there is a problem with this. This code, small little function of mine, is inside the main scope, right? Can it see num in there? If I write over here print num inside the lambda, will it see that num? Is it in its scope? Does it have access to it? Or if I say over here, can I say over here, num is equal to 20? Can I do that? Okay? You can, and it's through here. So in here, you can actually tell if you want to access the values and variables inside the scope by value, no access, by value, or by reference. You can access stuff by value, which means you can access num in here and do something, but that's a copy of num. You can make it over here so it becomes a reference. So when you change it, the stuff outside changes. We can do all these things. We're going to go through it soon. But this is just lambda intro. I don't know. Yes?
Just out of curiosity, teacher, usually when you create a function, it's so you can reuse the code later.
No, no, no. Not now. Not anymore. That's IPC. In this case, you just wanted a function to make your bigger function active. You don't want to reuse it. You just want to, and it's going to be reused every time it's called. But every time that it goes to line 13, it's going to reuse it. Yeah, so if you want to reuse something, don't use lambda. Lambda is not for that purpose. Or if you want to reuse it, then put auto equal and then use it in this scope. I could write over here auto v no student equals, and I write over here valid number of students. I could do that, and you can reuse it in 5 different things in this scope. So you can do a reusability, but and you can put it outside as a global variable, then it becomes a function. But why? Global variable? Yes. Well, why? It's a regular function. We had that before. So it is possible, but it's you can reuse it, yes, but and then you have to extern it like a regular variable. Why? Just write a function and add a prototype and be done with it. Okay? People at home, are we good? All right. The next thing I want to talk about, so the next time you're coming, I wanted to start this, but I'm not going to do it because it needs visibility. You have to be all in a lab when I'm teaching exceptions. I'm going to first teach exceptions, then I'm going to go through lambdas and all the good stuff in detail and explain how things work. But to teach you exceptions, we all need to sit, and I should tell you how to throw balls and stuff around. So for that, you have people at home won't be able to see me throwing balls. So that's why we're not going to do it. So please remind me the next time you're coming for that, we have to continue with exceptions. Okay? And so we know kind of what lambdas are. We know the full syntax yet. So it's a good time to go and study them, see what they are, so you can come back with the knowledge. Functors, you know, there is nothing else to talk about. Function pointers, we know there is nothing else to talk about. We will continue with exceptions, and that's that. I'm not going to teach anything else because anything that I want to teach needs at least half an hour. So, and we have 11 minutes, so that's not going to work out. Questions? Quiz? Pardon me?
Yeah, do you remember
Yeah, you want to do a quiz when you come. So I'm going to explain what, essentially I'm going to give you an aggregation, and I'm going to tell you to apply rule of 5. That's going to be your question. But I'm going to send a notice for you, official thing through announcement on Blackboard. On that, I'm not going to put it in Teams because there are 2 sections, people are going to get confused. Okay? So, but you are going to have the same demo test So it's a test to check and see how you are submitting your get 0 in it. So later on, you don't come back and say, oh, I forgot to click on that thing. Please give me 2 marks on this. I don't want that. I want you to know that it is a vital thing in your test that you give me an organized code. I don't care about spelling mistakes. I don't care about missing semicolons here or there. If you are doing the logic properly and I can read the logic, it's fine. You don't have to have perfect indentation as long as you have something that I can know where the scope ends. I don't have to jump through hoops through it. The reason is that when you are marking 30 students and people write garbage, it becomes so difficult to mark that I'm going to make mistakes. This is not IPC 144 that is just a loop and I say, okay, I know what it is. You are writing crazy stuff that I need to see if it works or not. So I need it to be organized. And you are in 3rd semester. If you cannot write organized code, you're in trouble. So you'll see that demo, and the videos, I think I've seen the video already, if you click on a video. But I changed the quiz editor. It's a true or false. Now you're actually selecting something. It says, I confirm that if I do that, I'll get something. So you gotta actually to me. If the person got 10 in that demo, show them the quiz. So if you don't agree to that, you're not going to be able to see the quiz. Remember that. Okay, you have to do that test. That's it. Questions? Suggestion? Oh, somebody's raising hand. Aaron, talk.
So for lambdas, and this might just be something you're going to cover next class, is it the fact that it just seems, as you presented it, not useless, but like it seems like it's overcomplicated and you just got rid of readability earlier when you removed the function.
You will see soon. I know, I understand 100% what you're saying. As if these guys just had nothing to do. Now let's add some stuff to make people, drive people crazy. But that's not the case. It really becomes useful. You will see soon.
Okay.
And I'm looking at the speaker.
Okay.
Somebody's in there now. Yeah, sure. Yeah, but you have to see it. Yeah. When by the time passes, and so C language was created by geeks, not beings who regular human people created COBOL and Pascal and languages like that that was readable. And then the geeks came through. They created something that was not high level, not low level. And now they're trying to make it high level so people understand, but every now and then they jump back to that geeky part. So we have all the parts. But you will have, I know readability is out the window. I understand 100%. But you will see that's going to be least of your problems when the time comes. Okay? Anyways.
Joy.
All right. I'll see you in the lab. Remember, be on time. We're going to do the quiz, and we're going to have a lecture. Okay? Or the other way, I don't know. So if you are not on time, if you lose the quiz, you're done. Careful. Have a good time. Oh, one more thing. Let me record this too for those people who are not listening. If you are a student with accommodation, you have a choice to come and do it in the lab. If you are coming doing it in the lab, you are not accommodated anymore. You have to start and end with anyone else, even if you have more time. If you want to use your accommodation, you have to go to the test center and do it there. Just letting you know. About it means it's not related to you. Easy as that. All right? Thank you. All right. Have yourself a beautiful day.